everyone, I am Jeneline Tamayo, and today I'm going to discuss about the queuing theory. Its definition, structure of a queuing system that includes the following: source population, arrival process, queue accommodations and behavior, selection process, service process and departure, and the basic queuing analysis assumptions. The queuing theory started as early as 1909. The Danish telephone engineer A.K. Erlang analyzed the queuing problems callers encountered at a telephone switchboard. Then, quantitative approaches have been developed to measure the operating characteristics and cost of waiting lines. These methods, often referred to as the queuing theory. So what is the queue? The meaning of queue is line or a sequence of people, vehicles, etc., awaiting their turn to be attended to or to proceed. Queuing theory is defined as the mathematics of waiting lines. It is extremely useful in predicting and evaluating system performance. It has been used for operations research, manufacturing, and systems analysis. Queuing system is defined as a system consisting of arrival of customers, waiting in queue, picking up for service according to a certain discipline, being serviced, and departure of customers. Here is an example of queuing system. So there is a system, there are customers, and there are servers. For example, in a hotel, there is a reception desk, there are people who are their customers, and there are receptionists that will guide or who are there to give service to the customers. Next, in a hospital, the customers are the patients who needs health attention, and then they are served by the nurses and so on. Here are some of the applications of queuing theory. The queuing model can be applied to various situations where customers are involved, such as restaurants, cafe, supermarket, airports, and etc. It's very useful in manufacturing units. It's applicable for the problem of machine breakdown and repairs, applicable for the scheduling of jobs in production control, applicable for the minimization of traffic congestion at a toll booth, and provide solution of inventory control problems. Characteristics of queuing system. Here are the key elements of queuing system. Customers refers to anything that arrives at a facility and requires service, such as people, machines, trucks, etc. Server refers to any resource that provides the requested service, such as repair persons, retrieval machines, etc. Waiting time, the time that the customer spends in the queue before being serviced. Time spent by a customer in the system. It is equal to the waiting time of customer plus the service time. Number of customers in the system. It is equal to the sum of number of customers in queue and the number of customers being served. Queue length. Number of customers waiting in the queue comprises the queue length. Jockeying. Joining the other queue and leaving the first queue. Reneging. Joining the queue and leaving it afterwards. Bulking. Customers decides not to join the queue. We will discuss this later in the slides. Characteristics of queuing phenomenon are the following: service center, service channel. Then the major constituents of a queuing system are the following: customers, the queue, and the service channel. As you can see, customers arrive in this area and then they fall in line, so that's called waiting line. And then one by one they will proceed to the service facility, wherein the counter, for example in counter number 1, will serve the customer, and then after the customer will be served, then it is his time to leave the area. Structure of a queuing system. In a typical queuing situation, customers arrive at a service system, enter a waiting line, receive service, and then leave. As you can see in figure 14.1, the customers arrives in the entrance area. That means the arrival process takes place. And then the customer will fall in line, so that is the waiting line. And then the queue length comprises the number of customers waiting in the queue. And there is a certain queue discipline. So it depends upon the facility or the establishment on what kind of queue discipline that they are using or following. For example, in the present situation, the customers must maintain at least 2 meters apart from each other because of this COVID crisis. And then the customers will be served at the servers one by one. After the customer is being served by the server, then that's the time that he can leave or he may leave the facility or establishment. Another example of a structure of a queuing system. The major components of any waiting line or queuing system are the following. Number one, calling population or input score. These are the customers. Number two, the queuing process. Number three, queue discipline. Four, service process or mechanism. As you can see, the customers will arrive. So the customers will arrive in this area at the entrance, and then they will go in this area wherein they are going to fall in line or wait. And then the number of customers waiting in the queue comprises the queue length. And there is a certain or particular queue discipline that is followed in the service system. And then one by one, the customer will go in the service facility area wherein the service process or mechanism will take place, and the customer will be served by the servers. And then after this, that's the time that the customer will leave or depart in the area. So as you can see, in between there is bulk. So what is bulk or bulking? It's when customers decides not to join the queue. Okay, so maybe he changed his mind, so he decides not to join the queue. Another one is reneging. Reneging is he already joined or he is already in the waiting line and decides to leave it afterwards. Maybe his mind was changed also. And then another one is jockeying. So jockeying is joining the other queue and leaving the first queue. So in the grocery store, for example, we may experience jockeying. So when the customer sees to it that the other counter is more faster, then he or she may decide to leave the first queue and then join the other queue or another waiting line in order to have a faster transaction. Source population, this can be finite or infinite. Finite or limited number of customers, and infinite or very large source populations. An example of finite or limited number of customers are in a clinic. So there is a maximum number of customers that they are going to serve daily. And then infinite or very large source populations. An example of this in a concert wherein there are large number of people entering the um, Colosseum or a gym, for example. Hence, it is important to identify whether a source population is finite or infinite in order to have a proper management and control in the situation. The arrival process describes the manner in which customers reach the service system. It is important characteristics involved in this process are the following: the form, composition, timing of arrivals of customers. There are two possible types of arrival processes: the deterministic arrival process and the random arrival process. The random process is more common in businesses. A Poisson distribution can describe the random arrival process. The two measures can be used to describe the arrival process. Number one is arrival rate. Gives the number of arrivals per unit of time. For example, that 960 automobiles reach a turnpike toll booth in an 8-hour period. Then, the arrival rate is 960 over 8 is equal to 120 per hour or 2 minutes. Number 2, inter-arrival time. Alternative measure and gives the interval between two consecutive arrivals. Since two automobiles reach the toll booth in a minute, there is 1 half is equal to 0.5 minutes or 30 seconds between arrivals. Notice that the inter-arrival time, 1 half, is the reciprocal of the arrival rate, which is 2. When service is provided on a scheduled basis, the arrival rate and inter-arrival time is fixed. In unscheduled situations, however, customers typically arrive in random pattern. That is, each arrival is not affected by preceding arrivals. There is a range of possible values for either the arrival rate or the inter-arrival time. Hence, in these cases, it is necessary to describe arrivals with a probability distribution that will be discussed later. Queue accommodations and behavior. Waiting lines may be accommodated in various ways. It is important to understand social and behavioral impacts of queuing. Manage customer expectations. Don't forget the line design. Give your customers something to do. Example, by giving them magazines and give reassurances. Provide a reason for the wait and make it equitable. Use technology. In a queue discipline, it is a rule according to which the customers are selected for the service when a queue has been formed. The common disciplines are the following: first come first served or FCFS. That means the first customer arrives in the area is the first customer that will be served. Next is first in, first out. So, just like the first come first serve, so the first customer that arrives in the area is should be the customer that will go out first. The third, last in, first out. So the last customer arrives is the first one that will be served and go out in the area. Next is selection for service in random order or siren. So we're in, there's a random selection, or the customers will be served randomly. There are different kinds of service processes that are being used. Number one, a single service system. As you can see, the customer arrives in the entrance and then fall in line in the waiting area and then being served one by one by the service facility. The service facility, there's only one person that will serve the customers, and then the customer, after being served, will depart the area. So example, your family dentist office library counter. There's only one server that serves the customer. And then another one is multiple parallel server single queue model. It's when the customers arrive in this area and then the customers will wait and there's a waiting line, and then after that, one by one, each customer will proceed to the service facility, okay, one by one. So There are three service facilities that will serve the customers. That means there's faster transaction and minimum length of waiting. And then after that, the customers will depart or go to the exit. An example of this is booking at a service station. Number 3. Multiple parallel facilities with multiple queues model. As you can see, in this model, there are 4 queues, 1, 2, 3, and 4, and there are 4 service stations, 1, 2, 3, and 4. So, as you can see, the customers will arrive in the first queue, will wait in this waiting line, and then will be served by the first station and then leave. And then the next one, the second queue, will be served by the second service station and then leave. And the third queue will be served by the third station and then leave. The fourth queue will be served by the fourth station and then leave. Number 4, service facilities in a series. As you can see, there are 2 queues and there are 2 service stations. So the customer arrives in this area and fall in line, wait in this area before proceeding to the phase 2, and then after that, the customers will wait in the in this waiting line and then proceed to the second service station before leaving the facility. Part 2. In some situations, it is important to consider what happens to customers after they leave the queuing system. For most systems, departing customers return to the source population and become potential new arrivals. Basic queuing analysis. There are many dimensions to consider when designing a queuing system. To evaluate alternatives, management must develop some measures of system performance. They should consider the operating characteristics of queuing models. That includes the queue length, system length, waiting time in the queue, the total time in the system, and the utilization factor. They must minimize the waiting time and the waiting line in order to improve their system. And there should be proper planning and follow up, just like having a drop box where customers may give their ideas and opinions regarding the system that they are implementing in order for the management to know the ideas of the customers in order to improve their system, to have a good customer and management relationship and satisfied customers. That's it. And thank you so much for listening. I hope you have learned something new today. I'm Janeline Tamayo. Thank you.